And launch team, be advised that it'll take about 10 to 15 minutes for the sequencing, for the range to sequence up the radars. So while they're in work on that, let's go ahead and bring up the transmitters on the vehicle. So Ops 1, you go for step 123, apply external power to vehicle transmitters.
Copy that, LC. Avionics telemetry transmitter, external power is on. Motor cone transmitter, external power on. And stage 1 telemetry transmitter, external power on.
And copy all, Ops 1.
And transmitter external power is nominal.
And Elec 1 confirms external power status nominal.
Roger that, Elec 1. We can check 123, 124, and 125. And PM step 126, can you confirm range is receiving open loop telemetry from vehicle on all links?
Stand by.
And PMLC, countdown 1.
LC, NASA PM.
Yeah, looking for status on step 126.
126, range is receiving open loop link 41, 69, and 87.
Copy that. So PM, you can direct range TM to switch to recording open loop telemetry.
Roger, in work.
Core 1 LC, countdown 1.
Go ahead, LC.
Yeah, step 285, direct East Norway to conclude their first MS session at T-minus 2 hours, 40 minutes.
Copy and work.
And PMLC, countdown 1.
LC, go.
Yeah, looking for status on the range TM switching to recording open loop.
Range is recording open loop to telemetry.
Okay, copy that. And PM, you're going to begin your S-band assessment?
Roger, that's in work.
Roger that. Okay, TLM step 129, configure decom source for open loop.
LC TLM in work. LC TLM, decom switch to open loop telemetry.
Roger that, TLM. And let's go ahead and verify we have open loop telemetry received and nominal. TLM.
LC TLM in work. LC TLM, open loop telemetry received and nominal.
Copy that. And is that MCC? Can you also verify RCC cap? Stand by. MES2, can you verify we have open loop received and nominal in the RCC cap?
LCMES2, open loop telemetry received and nominal.
Copy that. And SLM, can you verify we have open loop telemetry received and nominal in H100?
LC, this is SLM, open loop telemetry received and nominal.
Okay, roger that. We'll check step 130 complete. Okay, launch team, just be advised, we are in a sequence of C-band radar power-ups here, and once that's done, they'll go ahead and perform the C-band eval. We are performing, or we are in open loop right now, and the S-band assessment is ongoing. So we're going to hold open steps 131 and 132. In fact, we're going to hold open the remaining steps of the open loop RF transmitter checks through step 135. We will proceed in a few minutes here into our FTS and power systems test and just perform that on open loop.
LC, this is Site Control on countdown 1.
Yeah, go ahead, Site Control.
I wanted to verify you that the rod and cap pressure adjustment is complete and our required 200-foot clear is no longer required, so that is step 94 complete.
Copy that, Site Control. We can check step 94 complete. And Red Team Lead LC, countdown 1, be advised our 200-foot clear has been...
And LC, Red Team Lead, you cut out there.
Okay, Red Team Lead, sorry. Just want to be advised that our 200-foot clear has now been lifted.
Copy that.
Okay, launch team LC, countdown 1. I want to press into our FTS and power systems tests at this time. Let's go ahead and poll for FTS external power on. Safety?
Go for safety.
GSO?
GSO, go.
And FSO?
FSO, go.
TD?
TD's go.
Ops 1?
Ops 1 is go.
Ops 2?
Ops 2 is go.
Elect 2.
Elect 2 is go.
Okay, we'll go for FTS external power on. And FSO step 137, bring up command transmitter with check channel on.
FSO in work. Step 137, this is FSO, WAP CT site on, check channel radiating.
And I copy FSO. We can check 137 complete. Ops 1, step 138, apply external power to FTS-A and FTS-B.
LC Ops 1, FTS-A, external power on. FTS-B, external power on.
FTS external power nominal.
Copy all. Check 138 and 139.
FTS safe, receiving check channel, signal strength nominal.
Copy. Elect 2. We'll check step 140 complete. And launch team on a poll for avionics and FTS internal power test. GSO?
GSO, go.
FSO?
FSO, go.
TD?
TD's go.
Ops 1?
Ops 1 is go.
And Elect 1.
Elect 1 is go.
And we'll go for avionics and FTS internal power test. Ops 2, start battery logging.
LC Ops 2 and work. LC Ops 2, battery logging on.
Roger that, Ops 2, and verify nominal lithium-ion battery monitor comp.
LC Ops 2 and work. LC Ops 2, lithium-ion battery monitor comm nominal.
Okay, roger, Ops 2. We'll check 143. And Ops 1, you go to transfer avionics and FTS power to internal.
And all internal power on command sent. 14:36:15.
Roger that, Ops 1, and your go for all for avionics and FTS external power off.
And all external power off.
Internal power is nominal.
Roger. Elect 1, I copy that. So we'll check 145 and 146 complete. And PM, LC, countdown?
Go ahead.
Yeah, can you verify with range radar we've had no change in C-band operation, and verify with range telemetry we've had no change in S-band operation?
LC, NASA PM.
Yeah, PM, this is LC, go ahead.
Yes, step 120, all 8 radars are active. Step 121, we are locked. Step 122, we are in the middle of the C-band evaluation.
Okay, PM, I copy that. I'll hold 122 open. And PM, what is the third radar, backup radar we're using for today?
3, number 3.
Copy, number 3. And PM, could you give me a step 148, which is, can you verify if range telemetry saw no change in S-band operation?
Yeah, stand by on that.
LC, Core 1 on countdown 1.
Go ahead, Core 1.
Yeah, I've got step 285 for you now. The first MS session has been complete.
Okay, copy that, Core 1. We'll check 285 complete. And TLM, step 286, you can disable the use NOIA data string.
LC, TLM, data stream suspended.
Okay, roger that. We'll check 286. And GSO LC countdown 1, you can begin implementation of the pad clear zone, and we'll hold that step until that's completed.
This is GSO. 1190 is set. Over.
Okay, copy that. And GCE LC countdown 1, step 288, provide direction on HPGN2 circuit configuration.
NLC, this is GCE. We'd like to initiate nitrogen on the primary circuit.
Okay, I copy that. Check 288. Prop 2 LC countdown 1.
LC, prop 2.
Yeah, step 289 will be required. Step 290 will be not required for today's op. And your go for step 289.
Prop 2 copies. Step 289 is in work.
And Ops 1 LC.
Good.
Yeah, you're going to switch avionics and FTS external power on.
Okay, do we want to do that before we verify no change in S-band?
Yeah, sorry, stand by.
LC, NASA PM.
Go ahead, PM.
We should, once step 122, you should see the C-band evaluation. We've got step 131, C-band evaluation, or S-band evaluation should have been delivered. Step 147, verify the range. We are nominal. We confirm nominal, as well as telemetry is nominal. Step 148.
Copy all there, PM. Thanks for the update. Okay, Ops 1, we'll press with step 149.
And I copy that, switching to all external power on. And FTS-A, external power on. FTS-B, external power on. 149 complete.
And you go for 150. You can switch avionics and FTS internal power off.
And all internal power off. Command sent. 14, 42, 13.
Hey, LC, this is Prop Lead. We need to switch the DN2 to the secondary supply.
Okay, Prop 2, you go to swap to secondary side.
Avionics external power is nominal.
Copy that, Elect 1. Check 151 complete.
LCMES2, PSPI indicates GN2 charging.
Roger that. We can go ahead and check 291 complete. And Prop 2, look for your confirmation that we're on secondary.
LC, prop 2, step 290, high pressure GN2 charging on secondary.
Okay, roger that. Ops 2 LC, step 152, you can remove the lithium-ion battery monitor power and discontinue logging.
LC, Ops 2 and work.
LC Ops 2, lithium ion battery monitor power off, logging off.
And Ops 2, I copy that. Okay, launch team, at this time we're going to go ahead and press into our FTS internal power and arm command test. And red team lead LC, countdown 1.
It's red team lead, go.
Yeah, be advised, 400-foot launch pad clear is going to be required during FTS internal power and arm commanding. Can you confirm clear?
Confirm clear.
Copy that. We'll check 153 complete. Okay, launch team, want to poll for FTS arm command test. FSO?
FSO, go.
TD?
TD's go.
Ops 1?
Ops 1 is go.
And Elect 2?
Elect 2 is go.
Okay, we'll go for FTS arm command test. Ops 1, transfer FTSA and FTSB to internal power.
LC Ops 1, FTSA internal power on, and FTSB internal power on. FTSA external power off, FTSB external power off. 14:45:31.
Copy all, Ops 1.
And FTS status nominal.
And LCGC on countdown.
Stand by.
FTS internal power nominal, ready for FTS receiver arm.
Roger that. We'll go ahead and check steps 155, 156, and 157. FSO, step 158. Send the FTS receiver arm command for 2 seconds and continue check channel when function removed.
FSO in work. Arm on my mark. 3, 2, 1. Mark. +1. +2. Arm removed. Check channel continued.
FTS arm indication received. FTS currently indicates safe.
And FSO, verify FTS arm indication.
FSO, FTS arm indication.
FTS safe and arm and FTLU2 are safe.
Copy all, Elect 2. Ops 1, you can open the FTS umbi loop and verify green indication.
FTS umbi loop open, green indication.
Copy that. Check 162.
FTLU and FTS receiver indications are nominal.
Roger, Elect 2. Check 163. Ops 1, you can close the FTS umbi loop and verify red indication.
FTS umbi loop closed and red.
And you can transfer FTSA and FTSB power to external.
Copy that. FTSA external power on. FTSB external power on. FTSA internal power off and B internal power off. Time 14:47:18.
FTS external power status voltage and current nominal.
Copy all. We'll check 165 and 166.
FTS safe, configuration verified, check channel being received. Are you ready for the AGCs?
Ready for readbacks. Ready for readback.
FTLUA is 4.84. FTSB is 4.85.
Copy all, Elect 2. We'll check 167 complete. Okay, launch team, we'd like to get GCE, safety, and GSO, and GCE. Who else do you need over on Anomaly 1?
RCE, prop lead, prop A.
Okay, copy all, and LCA will be monitoring that conversation. Okay, launch team, we're going to continue to press through our SNA arm and ODM enable test at this time. And red team lead, LC, countdown 1.
Red team lead go.
Yeah, be advised, we want to continue to maintain that 400-foot launch pad clear as we're going through our arming test here. Can you confirm clear?
Confirm clear.
Copy that. Check 168. Ops 2 LC, step 169, initialize ground EPV power supplies.
LC Ops 2, ground EPV power supplies initialized.
And you can initialize the ground ordnance power supplies.
LC Ops 2, ground ordnance power supplies initialized.
Check 169 and 170, and Ops 1 transfer FTS-A and FTS-B to internal power.
Copy LC, FTS-A, internal power on, and B, internal power on. FTS-A, external power off, and FTS-B, external power off. 14, 50, 49.
Roger that, Ops 1. Check 171 complete.
LC TLM 2, countdown 1.
Go ahead, TLM 2.
Looks like we had some data crash a lot of the display clients, so you want to close those and reopen them, and we'll reset our up to our VLC limits after everyone gets up again.
Okay, launch team, be advised you need to close out your GTLM sessions and reopen those, and then we'll go ahead and restart.
Yeah, just the ones that aired out. Not all of them have.
Okay, copy that.
And FTS internal power parameters are nominal.
Roger, LEC 1. We'll check 172. And Ops 1, step 173, can you activate arm enable?
LC Ops 1, arm enable rotated and illuminated.
And you go to send all arm command.
And sending all arm on my mark. 3, 2, 1, mark. All arm command sent.
Ground ODM armed, stage 1 controller armed, flight computer ODM armed, stage 2 ignition and aura armed, FPS A and B armed.
Copy all there, elect 1. Ops 1, safe the vehicle SNAs and vehicle and ground ODMs and verify ODM safe.
And in work. All safe sent, verifying SNAs.
All ODMs and aura and SNAs are safe.
Copy all there, elect 1. We'll check 176 and 177. Step 178, Ops 2, you can reset ground ODM power supply.
Stand by and work. LC Ops 2, was that a call for step 178, reset ground ODM power supplies?
Affirm.
LC Ops 2, ground ODM power supplies reset.
Roger that, Ops 2. Ops 1, you can transfer FTS-A and FTS-B to external power.
Copy LC, FTS-A, external power on, FTS-B, external power on, FTS-A and B, internal power off, time 14:54:06.
Copy all, Ops 1.
FTS external power status, voltage, and current nominal.
Copy that, elect 1. Ops 1, you can remove FTS power.
In work. And FTS A and B, power off.
Roger that. Ops 1. FSO, you can secure CT site and verify RF silence.
FSO in work. LC, FSO, and 182. CT site keyed down, RF silence verified.
Copy that. We'll check 182 complete. Ops 1, deactivate arm enabled, the fail-safe panel.
Arm enable key rotated and arm enable no longer illuminated.
Copy that. Ops 1, check 183. PM, can you see C-band transponder interrogation and deactivate radar sites?
Yes, sir. In work. Stand by.
Copy and work.
LC, elect 1.
Select 1 LC, countdown 1.
Yeah, step 132, the assessments are received and nominal.
Okay, copy that, elect 1. TLM, LC, step 133, switch decom source to closed loop telemetry. Roger that. We'll check 133. I want to verify we have closed loop telemetry received and nominal. TLM, MCC.
LC, TLM, closed loop telemetry received and nominal.
Roger that. MES2 for the RCC cap.
LC, MES2, closed loop telemetry received and nominal.
Roger that. And SLM for the H100.
LC, this is SLM, closed loop telemetry received and nominal.
Copy all. We'll check 134 complete. And PM step 135, you can direct range TM to switch to recording orbital decom source.
Roger, that's in work. LC, NASA PM.
Yeah, go ahead, PM.
Sir, I can give you step 184, C-band transponder interrogation stop, radar sites deactivated.
Copy that. And status on 135.
Step 135, range recording orbital decom source.
Roger that. We'll check 135 complete. Okay, launch team LC, countdown net with an updated status. We're complete all steps. The open loop RF and transmitter checks now are complete, and we've also performed our FTS power systems test. That's also complete, and we've also completed our SNA ARM and ODM enable test. We're back on closed loop telemetry at this point. We have a team working on the anomaly net. We are likely going to be sending the red team back to the pad to do some regulator adjustments out there at Skid 414. We're putting that plan together now. As soon as we have that together, we'll brief the team on it. And GCLC, countdown 1.
GC on countdown 1.
Yeah, step 292, can you provide direction on the warm helium circuit configuration?
Yeah, we'd like to initiate warm helium charging on primary.
Okay, copy that. Prop 1, step 293, you're going to initiate warm helium charging on primary. Step 294 will not be required.
In work.
And LC Prop 3, I have step 300 for you. Start of heated GN2 supply.
And LC Prop 1, warm helium charging started on primary.
Copy that, Prop 1. We'll check 293.
And LC Prop 3 on countdown 1.
Yeah, 3, go ahead.
Yeah, I have step 300 for you. Start of heated GN2 supply verified.
Copy that. We'll check 300 complete. Go ahead, GSO. Okay, launch team LC countdown 1 with the status. We're going to go ahead and send the red team out to the pad right now. They're going to go out to skid 414, and we're going to do adjustments to GN2 regs as we're out there. Currently, the vehicle is safe to approach. We have approval from this from GSO, and red team lead has confirmed the plan that's required. Red team lead, you're go to proceed to the pad at this time.
Copy en route and switching over to ANOPS 1.
And safety LC countdown 1.
Go for safety.
Yeah, sorry, safety. Yeah, I want to get your concurrence as well.
I concur for red team entry.
All right, roger that. Thanks, safety. Prop 1 LC on countdown 1.
LC Prop 1, go ahead.
Prop 1, your go for step 301. Adjust EREG 5269 to 1350 PSIG.
Copy. LC Prop 1, 5269, adjusted to 1350 PSIG.
Okay, I copy that, Prop 1. We'll check 301 complete. Okay, launch team. Red team has arrived on site at the pad right now. They're observing the valves that are regulator valves that are under question right now. We are still currently in our lulls chill down phase of the sequencer. 10 minutes, we'll expect LO2 flow rate for phase 3 chill down. As far as the vehicle goes, we've completed all of our testing with our S-band open loops. We've also completed all of our FTS testing and SNA arming. We have left to get through our EHS functional testing, but that will require pad clear, and we'll have to wait till we get Red Team out of the pad before we can press on that. We have enabled our warm helium system as well, and however, we are going to hold off on charging engine bottles until, again, that we are able to clear personnel from the pad.
LC Ops 1, stepping off comm.
Copy, Ops 1.
1 back on station.
At LCTD, we're agreeing on toxin debris.
Copy that, GD.
And LCGCE on countdown 1.
Go ahead, GC.
Yeah, the red team has completed their operations at the pad. We were able to restart the nitrogen flow to the vehicle, and that's looking nominal. And they also reset the backup reg for helium, and that is also in the nominal band now. We are all clear to go.
Okay, copy that, GC. Appreciate that. Okay, launch team, once we get confirmation that the red team is outside the gate, we'll be able to proceed with the start of charging on the engine helium bottles. We'll also be able to kick off the HS functional tests here. We're about 15 minutes behind on getting to some of this work here, so we'll be moving relatively rapid pace as we step through these. Okay, launch team, we have received confirmation that the red team is outside the gate. That gives us our 293-foot clear, and we can proceed with the next portion of our countdown here. Okay, launch team, I've been advised that the red team lead is back at building Z65. We can check step 295 complete. Prop 1 LC, countdown 1.
LC Prop 1.
Yeah, step 296, you go to start charging of engine helium bottles.
In work. And opening VTD on my mark. 3, 2, 1, mark. LC Prop 1, engine bottle charging started.
Copy that, Prop 1.
And helium bottles charging.
Roger that, MES2.
LC, admin unloading, VTD state set.
Roger, admin, check 297 and 299. And Prop 1, I'll wait for your call on 298.
Standby 1. LC Prop 1, OCCS in auto mode.
Copy that. We'll check 298 complete. And prop lead LC, countdown.
Prop lead, go ahead.
Yeah, prop lead. Did you get step 303 status on the LO2 flow rate for phase 3 chill down?
Hey, actually, this is prop 3. I can confirm that the phase 3 flow rate is nominal and we do not need adjustment. So
Okay, good. Copy that, 3. And launch team again, we have 303 and step 304 will not be required. Core 1 LC, countdown 1.
Go ahead.
Okay, you can direct Easnoid to begin their second MS session at T-minus 1 hour and 40 minutes.
In work.
Break on anomaly 1. Break on anomaly 1. We want to get a poll for EHS functional testing at this time. Okay, launch team LC, countdown 1, step 185. I want a poll to perform our stage 1 EHS functional testing. GSO?
GSO, go.
Prop 2?
Prop 2 is go.
Prop lead?
Prop lead is go.
Ops 1?
Ops 1 is go.
Ops 2?
Ops 2 is go.
EHS 1?
For EHS 1 and 2, EHS is go.
Copy all. MES 2?
MES 2 is go.
ACE?
ACE is go.
And we'll go for EHS functional testing. And Ops 2, step 186, initialize ground EPV power supplies.
LC Ops 2, ground EPV power supplies initialized.
Ground EPV power supplies initialized, voltage nominal.
Roger, LEC 1. Ops 1, step 188, activate arm enable.
Arm enable rotated and illuminated.
And you go to arm ground ODM.
Ground ODM armed.
And verify GSM EPV ODM arm.
Ground EPV ODMs indicate armed. Ground ordnance ODMs remain safe.
Copy all, Ops 1.
LEC 1 confirms. Ground ODMs 437 indicate arm.
Copy, LEC 1. Ops 1, step 192, deactivate arm enable.
Arm enable rotated and no longer illuminated.
Roger that. And Ops 2, step 193, you can set ground EPV VREFs.
LC Ops 2, ground EPV VREF set.
And LEC 1 confirms. Ground EPV VREF set, voltage nominal.
Roger, we'll check 193 and 194. And launch team, I've already confirmed with red team lead on step 195 that we have a 51-foot clear. We actually have a 293-foot clear as well. Prop lead, step 196, verify accumulators 8006 and 8007 are ready for EHS functional.
Accumulators verified ready.
Roger that. Prop 2, step 197, place OCS in the SAC mode, pause the HSS ASC.
LC Prop 2, that's in work. LC Prop 2, HSS ASC is paused.
Roger that, Prop 2. You can open valve 8021.
And opening 8021 on my mark. 3, 2, 1, mark. LC Prop 2, 8021 is open.
HS hydraulic supply valve configuration verified.
Copy all. Step 200, Prop 2, configure HSS GN2 pressure to accumulators.
LC Prop 2, that's in work. LC Prop 2, 5464 is closed, 5463 is open.
HSS GN2 valve configuration verified.
LC I can verify EHS pressures are nominal.
Okay, copy all. We'll check steps 200, 201, and 202. Ops 1, step 203. Go to transfer SMI A and B power to internal.
LC Ops 1, SMI power A, internal power on, and B, internal power on. SMI power A, external power off, and B, external power off. SMI switch to internal.
And Ops 1, you can enable the ME1 and ME2 TVC in the HA buses.
And didn't work. TVC and EHA buses enabled.
SMI power nominal.
Copy that, elect 1. We'll check step 205 complete. Okay, launch team, we're going to press now into initializing our stepper motors and press into our cycles on our TVC sweep test here. So, Ops 2, you go for step 206, initialize stepper motors to their null positions.
Stand by, LC. LC Ops 1, it appears we might have some stale telemetry at GTLM again, standing by to perform that initialization.
All right, stand by. Let's stand by on step 206 as well.
LC Ops 1 prepared to initialize stepper motors to the null position.
Okay, copy that. And I just want to re-verify EHS 1. You are go to continue to with EHS functional at this time?
Yes, EHS is good.
Roger that. Okay, Ops 1, initialize stepper motors to their null positions.
Command sent 153300.
And EHS 1, report when stepper motors nulled.
Stepper motors at the null position.
Okay, Ops 1, step 208, set radio and conical ramp rates for EHS functional.
And in work. And ramp rate set.
And Ops 1, verify stop limit.
And stop limit set at 4.2 degrees.
And verify engine positioning mode.
Engine position is set to synchronized.
Okay, Ops 1, step 211. You go to start TVC actuator comm.
And TVC actuator comm has started.
Okay, Ops 1, we're going to start TVC sweep test at this time. Ops 1, you'll announce the start of each cycle, and EHS 1, I want you to confirm after each cycle. And how many cycles EHS 1 do you want to run?
We'll go with 3 cycles, LC.
Copy, 3 cycles. Okay, Ops 1, you'll go for step 212.
Copy, LC. Issuing the command to start the 4-degree radius conical slew test on my mark. 3, 2, 1, mark. And test in progress.
Sweep complete, ready for next cycle.
And moving to cycle 2 on my mark. 3, 2, 1, mark. Test in progress.
Sweep complete, ready for next cycle.
And proceeding with cycle 3, 4-degree radius on my mark. 3, 2, 1, mark.
TVC sweep complete and set.
Okay, copy that. The EHS-1 will check steps 212, 213, OPS-1, step 214, stop. TVC actuator com.
Actuator com, stop.
All right. Site control LC on countdown 1.
This is Site Control. Go ahead.
Yeah, can you verify ECS air dew points?
Yes, ECU core number 1 is negative 49.3. ECU core 2 is negative 49.5.
Okay, copy all. We'll check 306. Launch team, I can also advise we have step 305. I'll get a read back on the UTC times in just a minute here as we're catching up. Okay, site control, step 307, remove tail arm preload.
In work.
LCMES-1, step 302, warm helium system stabilization, stabilize, observe.
Copy that. We'll check 302 complete.
All right, this is Site Control on countdown 1. I'm going to go ahead and raise the TEL to 90.629 degrees. On my mark, 3, 2, 1, mark. We are building pressure. Should have motion. All right, motion complete. We have a final angle for null of 90.619.
Okay, site control, I copy that, and you're go to remove, you're go to command tell arms to open.
In work. All right, this is Site Control on countdown 1. I will be opening the gripper arms on my mark. 3, 2, 1, mark. We have motion. All right, motion complete. Gripper arms are open.
Okay, Site Control, I copy that. We'll check 308 complete, and you're going to remove gas power.
In work. LC, this is Site Control on countdown 1.
Go ahead, Site Control.
Gas is powered off. Step 309 complete.
Okay, stand by on step 310, Site Control. Okay, Ops 1, AHS 1, I want to continue with our AHS functional. Step 215, Ops 1, you're going to start EHA actuator comm.
EHA actuator comm started.
And Ops 1, start EHA sweep test.
And starting sweep on my mark. 3, 2, 1, mark. Test in progress.
EHA sweep test complete and set.
Copy. All Ops 1, stop actuator comm.
And actuator comm stop.
And disable ME1 and ME2 TVC EHA buses.
TVC and EHA buses disabled.
Copy that. Ops 1, you can close EHS hydraulic supply valve.
And I copy that. Closing 8020 on my mark. 3, 2, 1, mark. 8020 reports closed.
8020 verified closed.
Copy all. Step check 220 and 221. Ops 1, transfer SMI A and B power to external.
Copy that. SMI power A and B, external power on. SMI power A and B, internal power off.
LC, EHS1, hydraulic pressure has been removed from the vehicle.
Roger that. We'll check 222 and 223. And Prop 2, reconfigure HSS GN2 valves to pre-launch config.
LC, Prop 2, it's at work.
And I copy and work. And Site Control, you'll go for step 310, move tail to vertical position.
Site Control copies. In work.
HSS GN2 valves reconfigured, HSS GN2 venting.
Copy, Prop 2.
All right, this is Site Control. We are lowering the tail to 90.476 degrees on my mark. 3, 2, 1, mark. Tail is in motion.
And LC, prop lead, step 225, HSS GN2 is vented.
Copy that. Lead, check 225. Prop 2, Prop 2, I'll wait for your call on 226.
And LC 8021 is closed.
Copy that. Check 226 complete.
LC is Site Control on countdown 1.
Stand by, Site Control. Prop 2, I'll wait for your call on 227.
And that's in work. And HSS ASC resumed, OCCS in auto control mode.
Copy that. Okay, launch team, we're complete AHS functional testing, and Site Control, your go.
Yep, step 310 complete, tail is back at vertical.
Okay, roger that. We'll check step 310 complete.
NLC GC on countdown.
Go, GC.
Yeah, can we get a team to talk about anomaly with the high-pressure helium regulator?
Yeah, copy that. GC, so GSO and safety, if I can get you over on anomaly 1, and GC, who do you need technically on anomaly 1?
ACE, Mars 1, prop lead, Mars CE, sorry, and stage 1.
Okay, copy that.
And GCE, this is stage 1. Do we have a helium issue that I'm not tracking, or is this the nitrogen issue?
Sorry if I said helium, that was wrong. This is nitrogen.
Okay, launch team LC, countdown 1 with the status. We're sitting at step 311 on Lulls chill down. We're about ready to do our engine pressure switch checks. We did get a report from the range. Range is currently reporting red. They have a surveillance aircraft that is returning to the ground to do a reset on their radar. That surveillance aircraft RA-6. It'll be about another 25 minutes before we get a status from them on that radar asset. Okay, we're going to continue to press with our countdown. Step 311, I want to verify readiness to perform engine pressure switch check. MES2?
MES2 is go for switch check.
Ops 1?
Ops 1 is go.
And Elect 1?
Elect 1 is go.
Okay, we're ready for engine pressure switch check. Ops 1, activate engine pressure switch check.
And in work. And pressure switch check on my mark. 3, 2, 1, mark. Pressure switch check activated.
Engine pressure switch check nominal.
And a copy all. And we'll check 312 and 313. And TLM, step 314, you can enable the use NOIA data stream, internally use NOIA embedded stream output, the MS data recording workstation. Okay, copy that. We'll check steps 314 and 315. Core 1, LC, countdown 1. Core 1, LC, countdown 1.
Go ahead, Core 1, or LC.
Step 316 request, use NOIA to verify the orbital decom data is being received and recorded, and the MTU hardline data is being received and recorded.
Copy and work.
Copy that and work. Okay, launch team, we want to press into our discrete tests. At this time, step 228, report readiness for calibration of engine pressure sensors. MES2?
MES2 is go.
EHS1?
EHS1 is go.
And Elect 1?
Elect 1 is go.
All right, we're ready for engine pressure sensor cal. Ops 1, step 229, set engine pressure sensors to cal mode.
Engine pressure sensor cal to cal on my mark. 3, 2, 1, mark. And setting engine pressure sensor cal to flight. 3, 2, 1, mark. Sensors recalibrated and return to flight mode.
Engine pressure calibration executed, verified in flight mode.
Elect 1, I'm waiting for your call on step 230.
Engine pressure calibration executed and verified in flight mode.
Copy that. We'll check 229 and 230. Ops 1, step 231, set charge amps to flight mode.
Setting charge amp reset to flight. 3, 2, 1, mark. Set to flight mode.
Engine sensor charge amps verified in flight mode.
Copy that. Check 231 and 232. And Elect 1, report status, discrete signals.
Discrete verified nominal.
Okay, launch team, step 234. Let's go ahead and press our local launch enable button at the failsafe panel. Verify indicator illuminates. Ops 1.
Launch enable verified.
And GSO.
GSO, launch enabled verified.
Okay, and the RCC team, we want to do the same thing and verify we get launch enable verified. RSO.
RSO, launch enable verified.
FSO.
FSO, launch enable verified.
PM.
NASA PM, launch enable verified.
And TD.
Launch enable verified.
And Ops 1 verified, global launch enable.
Global launch enable verified.
Discrete's verified nominal.
Copy all. We'll check 235, 236, 237. This time we'll go ahead and cycle our local launch enable buttons and verify it disables and then re-illuminates when re-enabled. RSO.
In work.
LC, Core 1 on countdown 1.
Go ahead, Core 1.
Yeah, I've got step 316 for you. MS data is being received and recorded, and MTU hardline data is being received and recorded.
Copy that. We'll check 316 complete. And TLM, step 317, the TLM server, you can verify using only a stage 1 telemetry receipt via the Ethernet UDP link.
And LC, this is RSO for 238, launch enable cycled, indications nominal.
Copy that, RSO. And FSO?
FSO in work. On my mark, 3, 2, 1, hold. Release. FSO, launch enable cycled, indications nominal.
Copy, FSO. PM?
PM. Launch enable cycled, indications nominal.
Copy that. TD?
It work. Cycle, all indications nominal.
Roger that, TD. And Ops 1?
In work. Launch enable cycled, indications nominal.
And GSO?
In work. Launch enable cycled, indications nominal.
Copy, GSO. Okay, launch team, that completes step 238. GSO, you can remove your local launch enable.
Launch enable removed.
Copy that. And Ops 1, you can do the same.
Launch enable removed, verified off. Global launch enable, verified off.
Copy all. We'll check 239, 240, 241. That completes our discrete test checklist. Okay, TLM, going back to step 317. Can you verify you're receiving USNOIA stage 1 telemetry?
LC TLM receiving USNOIA stage 1 telemetry.
Copy that. All right, let's confirm that we have nominal USNOIA vehicle telemetry. TLM for the MCC?
LC TLM confirmed for the MCC and E100 room.
Okay, copy that. And ELEC 1?
Sorry, I'll see which step we on.
Yeah, ELEC 1, step 318, looking for confirmation of nominal USNOIA vehicle telemetry in room 111.
Yeah, ELEC 1 confirms.
Okay, launch team. Copy that. Okay, launch team, that completes 318. Just to be advised, step 319, we did hold CDT at the time 155003 Zulu, so check step 319. And MES2, can you get with LCA on countdown 2 and perform step 321 for me? Site control LC, countdown 1.
This is site control. Go ahead.
Step 322, can you re-verify ECS air dew points?
Yep. ECU number 1 is currently at minus 49.3. ECU number 2 is minus 49.5.
Copy that, site control. We can check 322. Do I have GC? Okay, launch team, be advised, GC on a backnet has given me step 323. Heated GN2 parameters are nominal at this time. And at this time, we're going to go ahead and get our updated weather briefing from LWO on countdown 1, step 324. And LWO, we're ready for that briefing.
Copy that, LC. This is LWO on countdown at 1, providing your updated weather briefing. Currently, we do have mostly sunny skies continuing, seeing the winds come up slightly, only seeing a peak wind of 18 miles an hour the past hour. So seeing those winds continue to increase slowly, expecting that increase more as we get to the next hour. Looking at our current conditions, our current weather, a few clouds around 7,000 feet as well as 25,000 feet off the northwest, seeing a southwesterly wind 7 to 12 knots, gusting as high as 15 to 16 knots, temperature 45 degrees, relative humidity around 45%, sea state, storm remaining at 3 feet. So taking a look at our current satellite imagery, you can see this bank of clouds in the 7,000 foot as well as 25,000 feet around 100 miles to the northwest. It's going to continue to remain off to our north and west and giving us those mostly sunny skies expected. And taking a look at the HERM model for the next few hours, you can see here this is 11 local and then 12 and then 1. You can see the winds increase just after T-minus 0 to 14 knots here, but still expecting very similar forecasts as was briefed earlier with our cloud cover remaining off to the north and west. So taking a look at our upper low wind field, we'll see this observed wind at 4.5 hours before T-minus 0, looking at winds around 153 knots out 40,000 feet out of the west-southwest, and that is our peak wind in the sounding. As you can see here, winds are continue to expect to decrease as we move towards T-minus 0 down to 132 knots at 40,000 feet. And taking a quick look at our trend, you can see here the observed balloons from 11, 12, and 13Z, and then a 18Z here just after T-minus 0 forecasted as the brown. You can see expected to continue to decrease once we move towards T-minus 0 with those upper level winds decreasing to near 130 knots. So taking a look at our countdown forecast, it's going to continue to see a few clouds around 7,000 feet as well as 25,000 feet. Winds out of a southwesterly direction, 7 to 12 knots, gusting to 17 knots, increasing out of the west-southwest, 11 to 16 knots, gusting to 23 knots, temperature rising from 45 to 48 degrees. We'll see relative humidity values still remaining between 40 and 50% and sea state at 3 feet. So looking at our launch forecast here at WALPS, similar sky conditions we are seeing now. We'll see winds increasing and remaining out of the west-southwest at 14 knots, gusting 25 knots, temperature around 48 to 49 degrees, relative humidity at 40%, sea state at 3 feet. And taking a look at our Bermuda weather, very similar as forecasted earlier, a little bit less low-level cloud cover, a few at 1,500 feet, scattered deck at 4,500 feet, as well as 25,000 feet. Very slight chance of a light rain shower moving north of the island, but overall should stay dry. And seeing a wind out of the southwest, gusting at 26 knots, so strong wind at Bermuda, temperature around 73 degrees, and relative humidity at 85%. So taking a look at our POV chart, currently green across the board, still highlighting a yellow for our surface winds, 25 knots we are forecasting, and that criteria is at 29 knots, and only a 25% chance of that being violated with this forecast. That'll complete the updated weather forecast. Any questions?
Okay, Elwell, thanks for that update.
Copy that, LC.
All right, Launch Team LC Countdown Net. We'll get an updated status here on range situation in just a few minutes. We have about 18 minutes remaining in our current CDT hold, after which we'll come out of that and begin propellant loading. We've completed all steps through step 324, the lulls chilled down. We'll confirm a pack clear zone here in just a few minutes, and also brief out our CDT resume time in just a few minutes as well.
Gas light assurance, gas.
Red Team Lead LC Countdown 1.
It's Red Team Lead, go.
Yeah, step 320, you can evacuate the Red Team to Victor 50 and then notify us upon arrival.
Copy all, Red Team en route.
Roger that. And GSO, I'll wait for your call back on step 325 after we've got Red Team out of the clear zone.
GSO, roger.
Okay, Launch Team LC on standby. Launch Team LC on Countdown 1 with an updated status. We just had a report from the range that the surveillance aircraft that had to return to the ground for radar reset is taxiing at this moment. We'll be going airborne again. We do have a CDT resume time planned for 162003. That's 16:20:03 Zulu. We have approximately 13.5 minutes remaining in our hold at this time. And although the range is currently red, we'll get a report once the aircraft surveillance is back on station and can report. Then we'll be able to hopefully be able to clear that. So at this time, we are planning to resume our countdown and press into our propellant loading on plan. Elsie out. Okay, Launch Team LC, we just had a report from TD at the range. The range is now green. The air surveillance aircraft has returned back on station, and radar is operational again. So once again, range is reporting green. And we're coming up on our pole to begin propellant loading operations. Just about 2 minutes here.
LC, red team lead, countdown 1.
Station calling LC.
Yeah, LC, this is red team lead. I can confirm that the red team is at Victor 50.
Okay, copy that, red team lead. Thanks for the report. And GSO LC countdown 1.
GSO, pad, clear zone established.
Copy that. We'll check step 325 complete. And launch team CDT will resume at 16:20:03 Zulu. And at this time, I want to poll for readiness to begin propellant loading operations. Mars site.
Mars site is go.
GSO.
GSO, go.
RSO.
RSO is go.
TD.
TD's go.
CMD.
CMD is go.
Safety.
Safety is go.
Prop lead.
Prop lead is go.
Stage 1.
Stage 1 is go.
GC.
GC is go.
ACE.
ACE is go.
LD.
LD is go.
We are go to begin propellant loading operations at T-minus 1 hour, 20 minutes. And launching that completes our lulls chill down and progressing into propellant loading operations. Okay, launch team LC, countdown 1. Countdown has resumed. We're at T-minus 1 hour, 20 minutes. TLM, step 329 at the decom. Stop, restart, telemetry archiving.
LC, TLM, and work.
And a copy and work. Site control, you go for steps 330 and 331. Arm and start RP1 tank, desk and hose retract, and arm and start LO2 tank, desk and hose retract.
LC, TLM, archiving restarted.
Copy that. Check 329.
RP1 desk and hose retract started. RP1 tank desk and hose visually verified retracted. LO2 tank desk and hose retract is started. LO2 tank desk and hose retract visually confirmed.
Copy all site control. Check 330 and 331. And site control, you can command tell to pre-pullback position.
Copy that. Pre-pullback command sent.
And Mars tell, I'll wait for your call on step 333.
Copy.
Okay, launch team, be advised, start a core low flow RP loading and low flow LO2 chill down will occur at T-minus 1 hour and 16 minutes. Phase 2 dynamic limits will be active. Check 334.
LC Marstel, pre-pullback is complete.
And I copy that. Marstel, we'll check step 333 complete.
And LC prop lead, step 335, on your report, low flow RP loading and LO2 vehicle chill down is verified.
Copy that lead. We'll check step 335 complete. And lead, I'll wait for your callbacks on step 336.
Yeah, stand by. And LC, this is prop lead. We are going to need to perform an adjustment.
I'm sorry, lead. You said you are going to require?
Yes, affirm.
Okay, copy that. So prop lead, you go for step 337 and report when complete.
Copy. LC RP1 low flow rate has been adjusted and complete.
Okay, lead, copy that. We'll check step 337 complete. And launch team will be coming up on the start of core high flow RP loading in just about a minute.
LCA Mars Phil on countdown 1. Yeah,
Go
Mars
ahead,
Phil, I'd
Marcel.
like to get site control on back channel to do a rapid retract GN2 recharge. Advise which channel.
Okay, copy that. Let's do it over on anomaly 2.
Copy, going anomaly 2.
And prop lead LC, countdown 1.
Prop lead, go ahead.
Yeah, can I get the call on step 338?
Oh, copy, yes. High flow RP loading is verified.
All right, roger that. We'll check 338 complete. Okay, launch team LC, countdown 1 with status. We're currently in our high flow RP loading. On the core, we're about to start our high flow LO2 chill down in just about a minute or two. After we clear that event, then we're going to go and refill our HSS accumulators for our final flight configuration on the HS. That'll be formed on a back net, but we'll announce to everybody when we're starting that. Currently at hour and 7 minutes from T0.
LC Marstel on countdown 1, recharge is complete.
Copy that, Marstel.
And LC, this is prop lead. High flow LO2 chill down has started.
Copy that, lead. We'll check step 339 complete. Okay, launch team LC on countdown 1. At this time, I want a report of readiness for accumulator refill. GCE?
GCEs go.
EHS? EHS 1? And EHS 1, LC, countdown?
Yeah, sorry, LC. EHS is go.
Copy that. Ops 1?
Ops 1 is go.
Prop 2?
Prop 2 is go.
And lead.
And LC is prop 3, I'll be taking this one.
Copy that, prop 3. We are ready for refill. Check step 340 complete. Okay, prop 3, you can proceed with the HSS accumulator refill, and that's appendix Mike. And are you, let's see, let's go ahead and perform that on standby.
Copy that, standby.
Why don't you go ahead and perform that on anomaly 3? How copy?
Copy that, I don't care. Anomaly 3.
Roger that. And launch team LC, countdown 1 with the status. We're passing through T-minus 1 hour and counting. Currently, all agencies are not reporting any issues at this time. And we are in the middle of our HSS accumulator refill, our standard procedure for doing that on a BACnet. Our next loading event will be occurring in approximately 4 minutes, and that's when we will transition to our start of our core low-flow LO2 loading. LC out.
And LC, this is Mars on countdown 1. Can I get a comm check?
And Mars, have you loud and clear? Help me.
Copy that, loud and clear. Thank you.
And LC, prop 3 on countdown 1.
Go ahead, 3.
I can verify that accumulator refill is complete.
Copy that, 3. We'll go ahead and check step 341 complete.
And LC, prop lead, low flow LO2 loading verified, step 342.
Copy that lead. We'll check step 342 complete. and launch team, we are passing through T-minus 55 minutes, and our next transition will be to high-flow LO2 loading in just about 1 minute.
LC, prop lead, high flow LO2 loading is verified, step 343.
Copy that lead. We'll check 343 complete. Okay, launch team, we just passed through T-minus 50 minutes and counting. Again, no agencies are reporting any issues that they're currently working. We are expecting to come up on the start of, we're expecting to come up on a decision to choose our flight computer trajectory file for today's operation, and we'll be making that decision in about 5 minutes or so, and then we'll upload that up to our flight computer. After that, we'll go ahead and begin our gyro compass alignment on our orb nav, and then after we go into that alignment mode, we'll be looking for confirmation that we have submerging of our cold helium bottles in our core. Elsie. And Launch Team LC, we're at T-minus 45 minutes and counting. GNC 1, step 344. provide the flight computer trajectory file for today's launch operation.
LC GNC1, we would like to select trajectory file 2 for today's operation.
Okay, copy that. Trajectory file 2. Ops 1, step 345, you go to upload trajectory file number 2.
LC Ops 1, trajectory file number 2 selected and uploaded.
LC GNC1, trajectory file 2 verified in telemetry.
Roger that, GNC1. We'll check 345 and 346 complete. And Ops 1, verify ground to vehicle comm is nominal.
And ground to vehicle comm is nominal.
Copy that. We'll check 347 complete. And Ops 1, let's go ahead and press with step 348, verify OrbNav settings.
OrbNav settings verified.
Roger that, and your go to initialize nav position.
OrbNav position sent.
OrbNav telemetry verified.
Okay, I copy all. We'll check 349 and step 350. And I want to get a report of readiness to begin gyro compass alignment. GNC1.
GNC1 is go.
Ops 1.
Ops 1 is go.
And elect 1.
Elect 1 is go.
Okay, we're ready for GC align. Ops 1, step 352, mode OrbNav to GC align.
Moding to GC align on my mark. 3, 2, 1, mark. Time 16:57:02.
ALC prop lead, I can confirm step 354. Cold helium bottles are submerged.
Copy that. We have step 354, lead. And launch team passing through T-minus 40 minutes.
LC, prop lead. Start of cold helium bottle charging. Verify. Step 355.
Roger that, lead. We'll check 355 complete.
LC safety, Countdown 1.
Go ahead, safety.
Stepping on the phone.
Copy that. TLM-LC on countdown 1.
Go ahead, LC.
Yeah, step 356, configure LV decom source to open loop.
LC, TLM, in work, and I'm also going to split the GTLM log one more time.
Copy that.
LC, TLM, LV decom switch to open loop. IRIG is 170125, and LV open loop telemetry being received and nominal.
Okay, roger that, TLM. We'll check 356 and 357. And NASA PM, LC, countdown 1.
Go, NASA PM.
Yeah, PM step 358. You're going to reactivate radar sites and reinitiate C-band transponder interrogation.
Roger, in work.
And I copy in work.
LC, GNC-1, step 353, warp nav telemetry verified.
Roger that, GNC-1. We'll check 353 complete.
LC, NASA PM, we are active with radars.
Copy that, PM, and I'll wait for your call on step 359.
LC safety, Countdown 1, back on call.
Copy that, safety. And PMLC, countdown 1.
Go ahead, LC.
Yeah, I'll wait for your call that range is holding beacon on all radars.
Yes, sir. We're still working.
Okay, roger that.
LC, NASA PM. All
Yeah,
radars
good.
locked.
Okay, roger that. Thanks, PM. Sorry for that. Okay, launch team, we are passing through T-minus 35 minutes. Ops 1, step 360, you go to enable local launch enable button at the fail-safe panel and verify indicator eliminated.
Launch enabled and illuminated.
And GSO, enable your local launch enable button at the failsafe panel. Verify local indicator illuminated.
GSO, launch enabled and illuminated.
Roger that. We'll check 360 and 361. I want to verify that the RCC enable abort buttons are enabled and illuminated. PM.
PM's enabled and illuminated.
Copy that. And RSO?
RSO is enabled.
And FSO?
FSO enabled.
And TD?
Enabled.
Copy all. We'll check 362 complete. Ops 1, verify master global launch enable.
Global launch enable, verified.
Launch enable verified.
Okay, copy all. We'll check 363 and 364. Ops 1, you can stop sending ECU commands.
ECU commands halted.
Copy that. We'll check step 365. Okay, launch team, in a few minutes we'll be coming up on our pole for our final FTS power on and our arm command test.
And LCTD, we're green for debris and toxic.
Copy. Range is green for debris and toxic. And launch team, we're at T-minus 30 minutes, step 366, poll for final FTS power on and arm command test. Safety?
Safety is go.
FSO?
FSO go.
Ops 1?
Ops 1 is go.
Elect 2?
Elect 2 is go.
Okay, we'll go for final FTS power on and arm command test. FSO, step 367, bring up command transmitter with check channel on.
FSO in work. LC FSO on 367, WAPS command site on, check channel radiating.
Roger, FSO, Ops 1, step 368, apply external power to FTSA and FTSB.
And FTSA, external power on. FTSB, external power on.
FTS external power nominal.
Check 368 and 369.
FTS safe, config verified, check channel being received. AGC nominal.
Copy, elect 2, Ops 1, step 371, transfer FTSA and FTSB to internal power.
FTSA and B, internal power on. FTSA, external power off. FTSB, external power off. 17:11:48.
FTS internal power nominal.
Copy, check 371 and 372. FSO, step 373. Send FTS receiver arm command for 2 seconds, then remove, continue check channel when function removed.
LC standby, we're evaluating AGC voltage.
Copy that.
Yeah, LC, this is FSO. We need to do a comet check.
Copy, you go for that.
Roger.
Understand, but they're seeing multipath, or I think they might be seeing multipathing right now. They need to verify. Okay, launch team, I want to go ahead and press ahead. I want to get a report of readiness for a recal of engine pressure sensors. MES2?
MES2 is go.
EHS1?
EHS1 is go.
Okay, we're ready for engine pressure sensor recal. Stand by.
LC, this is FSO.
Go ahead, FSO.
Comet results are good. Like to proceed with 373 at your command.
Yep, FSO sounds good. You go with receiver arm command for 2 seconds and then remove.
Roger, on 373, this is FSO. Arm on my mark. 3, 2, 1, mark. +1, +2. Arm removed. Check channel continued.
FTS arm indication received. FTS currently indicates safe.
And FSO verify FTS arm indication.
FSO arm indication.
FTS safe and arm and FTLU are safe.
Okay, I copy all. So we can go ahead and check 373, 374, 375, 376. And Ops 1 standby on 376, 378.
Standing by.
Okay, Ops 1, you're going to recalibrate engine pressure sensors.
Copy LC, engine pressure sensor cal to cal. Mark. Standby 5. and engine pressure sensor cal to flight. Recalibrated and ready for flight.
Roger that, Ops 1, and you're good to reset charge amps.
And charge amp reset, set the reset.
Charge amp signals reset, return to flight mode.
Roger, like 1, we'll check 378, 379, and 380.
Antares rocket, poised on top of the pad, towering 133 feet tall, fully fueled, ready to launch over 8,000 pounds of research, fresh food, technology demonstrations, and supplies to the International Space Station. This is Northrop Grumman's CRS-17 mission, and liftoff is set for 11:40 and 3 seconds a.m. Central Time, 12:40 and 3 seconds p.m. Eastern Time at the start of a 5-minute launch window today. The first stage is already loaded with its fuel to launch into space, liquid oxygen, and RP-1 kerosene. The second stage of Antares is a solid rocket motor.
LC Prop 2, HSS ASC is paused.
The weather conditions for today's launch are looking good. It's currently 45 degrees and partly cloudy with winds at about 18 miles per hour.
8021 now.
Teams all across the United States are supporting today's NG-17 launch. At the Wallops Flight Facility in Wallops, Virginia, which you see on your screen here, Northrop Grumman engineers are monitoring today's countdown from the Range Control Center.
Copy that. Lead Prop 2, you can resume the HSS.
They'll be counting down and walking us through the next 23 minutes until launch. And they'll be in the control room from the point of liftoff to when the Cygnus resupply craft separates from the vehicle's second stage. Just moments ago, a poll was conducted of the engineering systems, and everything is currently a go for launch. Also supporting today's cargo resupply mission is the team in Dulles, Virginia. Here, another team of Northrop Grumman engineers are standing by, ready to take over the flight of Cygnus after spacecraft separation occurs.
And Marshall, I'll wait for your call back when 388 is complete. Copy.
The destination for Cygnus following launch today and a 2-day orbit is the International Space Station. Teams in Mission Control Houston are also monitoring the operations of the space station and watching today's launch.
Roger that. We'll check 389 complete.
The flight director during this Orbit 2 shift is Judd Freeling.
Stage 1, LC, countdown 1.
Go ahead, LC.
Yeah, provide status of cold helium bottle supply pressure.
Yeah, we're still monitoring LC. We'll make a call between now and L-16 minutes.
The crew on board the International Space Station is enjoying their weekend with a day off involved with cleaning and exercising. There are currently 7 human beings living and working aboard the International Space Station as part of Expedition 66. From left to right, they are NASA astronaut Raja Chari and Tom Marshburn, European Space Agency astronaut Matthias Maurer, Roscosmos cosmonauts Anton Shkaplerov and Pyotr Dubrov, and NASA astronauts Kayla Barron and Mark Vande Hei. Vande Hei is in the midst of a record-breaking spaceflight in which he will become the American with the longest single spaceflight. He's on his way to surpassing Christina Koch's 328-day mission, which he'll break on March 3rd, and on March 15th, he'll break Scott Kelly's record of 340 days in space. When Vande Hei returns to Earth on March 30th, he will have spent a record-breaking 355 consecutive days in orbit. We're T-minus 20 minutes and counting until today's launch. No issues being worked by the flight control team at Wallops. It is a tradition for each Cygnus vehicle to be named after a significant space explorer who contributed to human space exploration. Today's Cygnus being launched is named the SS Piers Sellers after late NASA astronaut and climate scientist Piers Sellers. Piers Sellers began his career at NASA in 1982 and flew 3 times on the space shuttle aboard STS-112, STS-121, and STS-132. In total, Piers Sellers spent nearly 35 days in space, and as an astronaut, he helped build the International Space Station over the course of 6 spacewalks totaling 41 hours. We're T-minus 19 minutes and counting to today's launch. No issues being worked by the flight control team at Wallops. And joining us today is a special guest from Northrop Grumman to discuss today's launch. Christina Haloma is the Antares Systems Engineering Program Manager. Christina, welcome.
Thank you, Sandra. I'm excited to be here, and I'd just like to welcome all of you watching here in the United States and around the world to see a successful Antares launch and Cygnus mission to the International Space Station.
We're getting a look at the pad now of the Antares rocket. Christina, can you tell us some of the milestones we can look forward to ahead of today's launch?
Yes, so Sandra, there's still quite a few pre-launch milestones that are left here right before we launch. For example, we are currently at the tail end of the propellant loading operations. When that is complete, the team will top off the propellant and do some fuel adjustments. And then we'll do a final go, no-go poll that will be completed to proceed to final countdown here before launch. And then at approximately 3 minutes before we launch, the auto sequence will be initiated. That is where Antares' internal flight computers take over and commands the vehicle. So the auto sequencer then goes through the final steps of prepping the vehicle for launch and will proceed through the final countdown. But after liftoff, our team will be also monitor some post-launch milestones. The first milestone will be us waiting for the main engine to burn, and that'll happen for approximately 200 seconds until our main engine cutoff. And then once we get to the main engine cutoff, we'll go into a short coast right before we separate from stage 1 from stage 2, which we call the upper stack portion of Antares. After that, we'll continue to coast a little bit, and then about 30 seconds before starting that separation, and then we'll have an internal separation where the stage 2 flies out of the external upper stack. Once stage 2 is clear of the upper stack, the stage 2 will ignite for about 2.5 minute burn that puts Cygnus real close to their orbit, and then it'll coast and ensure everything is stable, and then Cygnus will be released into the desired orbit. And then after Cygnus is released, they'll go through their own comm checks, and then about an hour or hour and a half after we separate, Cygnus will then release its solar arrays and be on its way to the International Space Station. So all in all, from launch until Cygnus gets to its orbit is approximately 9 minutes. So it'll be fun to watch here post-launch.
It sure will. And Christina, this Cygnus mission is unique in that it has reboost capability. Can you discuss the Cygnus reboost capability planned during this mission?
Yes, so Sandra, in addition to delivering more than the 8,000 pounds of critical cargo to the astronauts living on the ISS, the Northrop Grumman Cygnus spacecraft will perform its first operational ISS reboost. Reboosting is a critical part of altitude maintenance for the International Space Station. What happens is the Earth's atmosphere causes a slight amount of drag, causing the station orbit to decay over time. So Northrop Grumman will perform the adjustment service while Cygnus is actually berthed with the station. So small, precise nudges are required to place the ISS back into its proper orbit. And Northrop Grumman is very proud to offer this standard service to NASA.
Today's operation.
Thank you very much, Christina. Christina Haloma with us today by phone.
And GNC1, LC.
Go ahead, LC.
Yeah, step 405, provide status of trajectory file for launch operation.
Now inside 15 minutes until launch, everything continues to proceed on track for today's liftoff scheduled at 11:40 and 3 seconds Central Time, 12:40 and 3 seconds Eastern Time.
LC, Core 1 on countdown 1.
Go ahead, Core 1.
So I've got step 397 for you. Fuel level adjustment is not required.
Copy that. Check 397 complete. And Prop 2, step 398 is go for ARM OCCS for no adjustment to fuel level.
LC, Prop 2, it's in work. And OCCS.
At this hour, propellant loading is now complete. Everything continues to be green across the board at Wallops. The weather's looking good. Everything all set for Antares to begin its flight to deliver the Cygnus resupply vehicle to its preliminary orbit, now less than 14 minutes from now.
Step 401 is not required. Step 406, not required. Step 407, not required. And launch team will be coming up on our pole to proceed with final countdown in a little bit over a minute. And CMD, I'll wait for your call on step 408.
LC, the CMD.
T-minus 13 minutes and counting.
LC, CMD. Cygnus is in launch mode and nominal.
Copy that, CMD. We'll check 408 complete. Okay, launch team, step 409. At this time, I want a poll to proceed with final countdown. GSO?
GSO, go.
RSO?
RSO is go.
TD?
TD's go.
Prop lead?
Prop lead is go.
Stage 1?
Standby 1, LC.
MES 1?
MES 1 is go.
GC?
GC is go.
ACE?
ACE is go.
Mars?
Mars is go.
Stage 1 is go.
Stage 1 is go. CMD?
CMD is go.
LD?
LD is go.
NG?
Northrop Grumman is proud to honor renowned NASA astronaut and climatologist Piers Sellers. Throughout his career, Piers made countless contributions to Earth and climate science, and his research revolutionized the methods for utilizing satellite data and analytics to increase our understanding of Earth's biosphere and changing climate. With unbridled optimism, dedication, and passion for the future sustainability of our ecosystem, Piers relentlessly strived for the betterment of humankind. It is therefore an honor to return his legacy to the International Space Station that he helped to construct, as the SS Piers Sellers and Northrop Grumman are go for launch.
Copy that, NG, and we are go to proceed with final countdown. Check step 409. And launch team will be coming up on engine evacuation in just a few seconds here. And hashtag Godspeed Little Noni.
And with that poll, we are go for today's launch of an uncrewed Northrop Grumman Cygnus cargo resupply vehicle named the SS Piers Sellers to head to the International Space Station.
Evacuation started.
Now under 11 minutes until today's launch. Following launch today, Cygnus will spend about 2 days catching up to the International Space Station. Cygnus is scheduled to be captured by the robotic arm of the space station in the wee hours Monday morning. Working that operation will be NASA astronaut Rajachari, and NASA astronaut Kayla Barron will be backing him up from inside the cupola. Rajachari will use the Canadarm2 to reach out and grapple the Cygnus vehicle.
T-minus 10 minutes.
LC MES1, step 411, vacuum verified.
Copy that, MES1. We can check steps 410 and 411.
At that point, Chari will turn over the robotic movements to a team of ground controllers here in Houston, who will maneuver Cygnus into an installation position to be bolted into place on the Earth-facing side of the Unity module. Cygnus will remain at the space station until May, where it will depart the space station and burn up harmlessly in the Earth's atmosphere. Our capture coverage is scheduled at 3:35 a.m. Central Time, 4:45 a.m. Eastern Time on Monday.
Ops 1 LC, countdown 1, step 412, you're going to enable ACS VDMs.
ACS VDMs, internal power on.
Copy.
ACS VDMs enabled, voltage nominal, ODM commands cleared.
Roger that, Elect 1, we can check steps 412 and 413. Launch team, be advised, step 414 is not required.
Now under 9 minutes until today's launch, everything's still looking good. And Antares has been switched to internal power. At about 3 minutes ahead of launch will be when the auto-sequence handoff to terminal count occurs, and the computers will take over for the final steps to get us to launch at the opening of today's launch window.
GN2 conditioning initiated.
Copy that. Check 415 complete.
Inside 7.5 minutes until today's launch, you'll continue to hear some of these countdown milestones ahead of today's launch. And at the time of launch, the International Space Station will be flying 261 statute miles over northern Algeria, just south of the Mediterranean Sea.
And passing T-minus 7 minutes. Ops 2 LC, step 417. You go to initialize ground ordnance power supplies.
Ground ordnance power supplies initialized.
LC top lead, step 416, BTSO activation verified.
Copy lead, copy Ops 2.
Ground ordnance power supplies nominal.
Roger that, Elect 1, we can check 416, 417, and 48.
Coming up on the T-minus 6 minute mark.
Half Bay ECS transfer to GN2 is confirmed.
Roger that, site control, check 419 complete.
Now coming up on the T-minus 5 minute mark.
T-minus 5 minutes. Ops 2, step 420, initiate engine priming.
Engine priming started.
Ops 1, transfer avionics to internal power.
LC Ops 1, avionics internal power on. Stand by. External power off.
Copy that. Check 420, 421.
Internal power nominal.
Roger, Lec 1, check 422 and Ops 1. Open FTS umbi-loop.
FTS umbi-loop open and green.
STOU and FTS receiver indications are nominal.
Roger, Lec 2, check 423, 424. Ops, send all arm command.
On my mark, 3, 2, 1, mark. All arm command sent.
SAs, ODMs, all arms.
Copy all. NASA TD, report range status.
LC priming verified.
CD's range is green.
Copy, range green. Copy, priming has been verified. Check 427 and 428. And launch team, be advised, phase 3 dynamic limits will be active at T-minus 3 minutes.
T-minus 3 minutes and 30 seconds until launch. Everything's still green across the board.
FC command into flight mode.
T-minus 3 minutes.
Auto sequence start. ODM bus voltages increase.
Less than 3 minutes until launch.
GNC 1, verify ready for nav mode.
LC GNC 1, orb nav ready for nav.
And Ops 2, step 435, switch to nav.
LC Ops 2, switch to nav.
Orb nav telemetry verified.
Copy that. GNC 1, check 436 and passing T-minus 2 minutes, 30 seconds.
Coming up on the T-minus 2 minute mark, Antares systems in good shape. There are no issues at this time.
T-minus 2 minutes. T-minus 1 minute, 30 seconds.
90 seconds until launch.
T-minus 1 minute.
Less than 1 minute until today's launch. At 40 seconds, tanks will be pressurized.
T-minus 30 seconds.
T-minus 15 seconds.
T-minus 10. 5, 4, 3, 2, 1. We have engine ignition.
Yep.
And
the Antares launch vehicle from launch flight facility. Engines are at 100% thrust. Altitude is nominal.
And we have liftoff of the SS Piers Sellers carrying over 8,000 pounds of cargo to the International Space Station. Good performance on the first stage so far.
Steady at 100% thrust and nominal. Engine still at 100% thrust and nominal. Valve VNO3 open. Attitude remains nominal. Electrical power is nominal.
Everything continuing to look good on Antares.
Through 25,000 feet. Passing through max Q, attitude remains nominal.
The first stage is now passing through max Q, the area of maximum dynamic pressure on the rocket. Now 90 seconds into today's flight of the Northrop Grumman Cygnus resupply cargo craft headed to the International Space Station.
The NG-3 now open. Engines remain steady at 100% thrust.
Coming up on the 2-minute mark of flight, everything looking good.
Attitude remains nominal. Power is nominal. (7,000 feet per second velocity). Attitude remains nominal. Attitude remains nominal.
Continuing to get good reports from the Range Control Center at Wallops.
Velocity now 11,000 feet per second. Power remains nominal. Beginning slow throttle down. Core pressures remain nominal.
Now 3 minutes into today's flight, throttle down will occur 3 minutes into the flight, which means main engine cutoff will be coming soon.
Now 55% thrust. And MECO.
We have MECO, or main engine cutoff. Antares now entering a coast stage. Fairing separation will occur about 30 seconds from now.
Stage 1 Delta V. Stage 1 is separated.
And as we lose sight of the vehicle, switching to our animation, there are some controlled firings of the inner stage of the rocket, everything continuing to perform as expected.
Stage 2 ignition at 246. Vehicle remains at nominal attitude. You have fairing separation.
Fairing separation confirms. Cygnus now exposed to the atmosphere as it continues its trek uphill to its preliminary orbit.
Stage 2 ignition.
Stage 2 ignition confirmed.
Stage 2 remains nominal.
Stage 2 is a solid rocket motor burn for about 2 minutes and 44 seconds.
TVC on is nominal. Power is nominal. TVC is nominal.
Continuing to hear all good calls now 4 minutes into today's flight.
Stage 2 performance remains nominal. TVC and attitude are nominal. Give me 100 seconds to burnout. Vehicle attitude remains nominal. TVC power and attitude remain nominal. Stage 2 remains nominal. TVC is nominal. Stage 2 remains nominal. Stage 2 motor pressure starting to tail off. Vehicle attitude remains nominal. And we have stage 2 burnout.
Stage 2 burnout confirmed. Cygnus has reached the preliminary orbital insertion. The next major event will be Cygnus's separation from the second stage, which will occur at about the 8-minute 51-second mark.
Antares is in orbit and will close for roughly 100 seconds prior to payload separation.
Everything's still performing as expected, now 7 minutes into today's launch.
Power and attitude remain nominal. Antares remains nominal. Approximately 30 seconds to payload separation. Vehicle attitude remains nominal, power nominal. We have payload separation.
Spacecraft separation confirmed. Cygnus now well on its way to the International Space Station.
Stage 2 attitude is nominal.
Can see the excitement in the room there as some celebratory fist bumps and high fives take place following today's successful launch.
And Prop 1 LC, countdown 1. Can you verify helium pulse purging is in progress? Copy that. And Prop 2, can you verify HPGN2 supply line post-launch purging?
LC Prop 2, GN2 line pulse purging is in progress.
Copy that.
Evening of March 21st. So thanks for joining us today, and have a good weekend.
Site control, step 449. Can you remove aft bay GN2 flow and reconfigure ECS for post-launch?
Aft bay GN2 flow is off. ECS reconfigured for post-flight.
We had a successful launch of the Cygnus cargo vehicle, launching at 11:40 a.m. Central Time, 12:40 p.m. Eastern Time today. With it, over 8,000 pounds of food, fuel, and supplies headed to the International Space Station.
Arm enable rotated and arm indication no longer illuminated.
And Ops 1, disable your local launch enable button.
Ops 1, launch enable removed.
And GSO, can you disable your local launch enable button?
And once Cygnus arrives to the International Space Station in the early hours Monday morning, it will be grappled and installed and then bolted into place. Following that, a series of leak checks at the berthing interface between Cygnus and the Unity module will be conducted to make sure that there's a tight seal between the Cygnus and the station. Following that, the process of hatch opening will begin.
Grandma, external power off.
Copy that. And TLM, it looks like we're LOS this time.
Hey, firm, LC.
Okay, TLM, you can stop telemetry archiving at the DCOM. You can stop MCC telemetry display, server distributor logging, and you can stop the G2 telemetry recording.
LC TLM and work will report when complete.
And if you're just joining us, the Northrop Grumman Antares rocket lifted off on time from the Wallops Flight Facility in Virginia from Launch Pad 0A at the Mid-Atlantic Regional Spaceport at 11:40 a.m. Central Time, 12:40 p.m. Eastern Time. Coming up in a few hours will be solar array deploy. We won't be covering solar array deployment live on air, but we will provide updates via our blog and social media. Again, it was a perfect ride to orbit. Cygnus now well on its way to the International Space Station with 8,300 pounds of food, fuel, and supplies on board. This is Mission Control Houston. Cygnus now safely in orbit heading to the International Space Station. We had a smooth launch from the Wallops Flight Facility in Virginia, and now joining us via phone is International Space Station Operations Manager Dina Cantella. Dina, welcome. Thanks so much for joining us today.
Well, thank you for having me. It's a beautiful launch. How can you hear me?
Thanks so much for joining us today, Dina. Now, with a successful launch and Cygnus on orbit, what's ahead of the operation? What's ahead for the operation teams?
Well, it was a beautiful launch. How do you hear me?
I can hear you loud and clear.
Great. Well, so ahead of the operations team, the Cygnus will perform a rendezvous with ISS, and when it gets close enough on Monday, the crew will use the Canadian robotic arm to grapple Cygnus, and then we'll attach it to ISS. And Raja's primed to operate the arm with Kayla backing him up. And those joint operations are planned to start around 11 p.m. Sunday night in Houston, the joint operations being between ISS and the Northrop team. And then that capture of the Cygnus vehicle is targeted for around 3:35 a.m. Central Time. So after that capture, the ground team will take over control of the arm to berth Cygnus to the Unity Nadir port, and that's the port that faces Earth. And we can expect the crew to be able to get the hatch open that same day on Monday, and that'll be maybe around 11:20 a.m. Houston time, depending on how things are progressing with the onboard operations. And the crew might be able to start some cargo operations on Monday, but the bulk of the first critical transfers are expected to take place in earnest really starting on Tuesday. And then we're expecting to have Cygnus attached to ISS until the end of May, and we're really looking forward to having all this cargo get on board.
And Dina, can you tell us a little bit about just how important it is to have these regular cargo flights?
Well, as you can imagine, these flights are critical for supplying the science investigations that make the International Space Station the incredible research facility that it is. And of course, the cargo flights also provide supplies for the crew and critical maintenance items and hardware to make the changes necessary to ISS to support new science. And so just some examples here on this particular flight of research that's coming up. Some examples include investigations looking at the effects of a drug on cancer cells. We've got investigations on skin aging, plant growth. We're looking at new hydrogen sensors. And you know, this science provides direct benefits to those on Earth as well as for future human spaceflight crews and future spaceflight. So, you know, this flight also is delivering some important hardware like another modification kit that'll continue our work to upgrade the solar arrays on board ISS. And some other key items that will be needed for a new capability that we're excited about to dispose trash items through the Antares airlock to help with some of our logistics. So I just say regular cargo missions are the lifeblood, really, of ISS's supply chain to continue research, and especially as we're continuing to extend station operations through 2030.
Thanks, Dina. And is there anything in particular that is unique about this mission that you're most looking forward to?
Well, yeah, in fact, this Cygnus vehicle has been modified to provide a capability to reboost ISS. And so it just uses some of its propellant in the vehicle itself. And we've done a test prior to this with Cygnus, but this will be our first real use of the capability to actually reboost the station. And it gives us another way to do so in addition to the Russian thrusters or the Russian Progress cargo spacecraft capabilities. So it's great to be able to expand our capabilities this way.
Dina Cantella, the International Space Station Operations Manager, joining us today via phone. Thank you very much, Dina. Appreciate it.
All right. Thank you.
Again, we had a successful launch of Northrop Grumman's CRS-17 mission on time today at 11:40 a.m. Central Time, 12:40 p.m. Eastern Time. To recap today's launch activities, the Northrop Grumman Antares rocket lifted off on time from the Wallops Flight Facility in Virginia from Launch Pad 0A at the Mid-Atlantic Regional Spaceport at 11:40 a.m. Central Time, 12:40 p.m. Eastern Time. Coming up in a few hours will be solar array deployment. We won't be covering solar array deployment live on air, but we will provide updates via our blog and social media. It was a very smooth ride to orbit, sending the Cygnus resupply vehicle to its preliminary orbit en route to a 2-day rendezvous that will result in Cygnus arriving to the International Space Station in the wee hours Monday morning. We'll be covering the capture of Cygnus, and our coverage will begin at 2 a.m. Central Time, 3 a.m. Eastern Time on NASA TV. NASA astronaut Rajachari will use the Canadarm2 to reach out and capture Cygnus at 3:35 a.m. Central Time, 4:35 a.m. Eastern Time. We'll then take a little pause, come back a couple of hours later for installation coverage, where Cygnus will be turned over to the robotic ground controllers here in Houston to install and bolt Cygnus into place on the Earth-facing port of the Unity module of the International Space Station. Our installation coverage will begin at 5 a.m. Central Time, 6 a.m. Eastern Time on Monday morning. With that, we'll wrap up our coverage of today's liftoff of the Antares rocket from Wallops to send Cygnus into its preliminary orbit. From all of us in Mission Control Houston, have a great weekend, and thanks so much for joining us today. We'll see you again on Monday. This is Mission Control Houston.